Find a basis and state the dimension of the subspace. So we have this type of elements where A, B, C are in R, and they are real numbers. So this vector, in fact, this generic vector is a linear combination of 4 vectors, because I can see A, B, C, D, arbitrary real numbers. So if I take A out from each component, then I have the following vector. So A means 1A, 1, 5A, no A means 0, no A means 0. B, here is negative 3B, so negative 3 here, there is no B, 1B is 1, no B, 0. C, 6C, so this is 6, no C, minus 2C, so minus 2, no C, 0. D, there is no D, 4D, so 4, minus D, so negative 1, and 3D, 3. So this H is in fact a linear combination, a collection of these 4 vectors. Now we need to find a basis. Basis means the collection should be spanning set and linearly independent. Obviously these 4 vectors span the subspace, because the subspace is given in this way, but we need to check if these 4 are linearly independent. If they are linearly independent, then that will be the basis, and there are 4 vectors and dimension will be 4. So we need to check if these vectors, let me see, v1, let me write this one, v1, v2, v3 and v4, if they are linearly independent. Okay, need to check if the vectors are linearly independent. Okay, if you see one is multiple of another, then we can basically just disregard that vector, because that is linearly dependent. Okay, 1, 5, there is none, so 0, 0, I mean there are no 0, 0s. Oh, here 0, 0, 1 times negative 2, negative 2, 0, 0, negative 3 times 2 is 6. Okay, so negative 3 times negative 2 is negative 6, 1 times negative 2 is negative 2. Oh, clearly now once you look at this, v3 is negative 2 times v2, because if we multiply v2 by negative 2, then we get this. So we don't need one of them. Okay, so v3 is in fact negative 2 times v2. So in this collection of bases we can disregard one of them. Now next consider just v1. We can disregard v3 and v2 and v4. Check if one of them is constant multiple of another, and that's not the case. So let's try. I mean, we might not have seen the linear combination. I mean, v4 still could be a linear combination of v1 and v2. In that case, we don't need all the vectors. So let's check if they are. Next, consider these 3 vectors and check if they are linearly independent. So how can you check that? We got 3 vectors. We can always row reduce. Okay, that's always works. 1, 5, 0, 0, negative 3, 0, 1, 0, and now 0, 4, negative 1, 3. So we want to row reduce and see how many pivots we get. We got 3 vectors. Okay, so this is 0, 0, good. Let's make this 0. So we're gonna work on R2, second row. such that R2 plus negative 5 times R1. Okay, so 1 negative 3 0, this is 0 1 negative 1 0 0 3, here negative 5 plus negative 5 0, 0 plus negative 3 times negative 5 15, 0 plus 15 just 15 here, and 4 plus 0 is just 4. Okay, and if we look at this closely here, this one, for this one we got pivot here, and we got 2 of them, right? So here, anyways, this column here is a pivot. We need to make this 0. Okay, so let's go one more step instead of working from here. Okay, so we had what we had here, this is 1, and we found that was 15, right? So let's make this 0. Okay, and for this one we can use R2, so we're gonna work on R3. R3 plus is a 15, so we need to multiply by negative 15, or we can multiply this, we need to multiply by negative 15, so let me write this way, negative 15 times R2, then R3, right, negative 15, then add with R2 plus R2. That gives us only working on R3, so 1 negative 3 0 0 15 4, here is now 0, that's negative 15 plus 15 0, and here is negative 1 times negative 15 just 15, 15 plus 4 19, and we got here 0 0 3. Okay, and in fact 0 0 19 0 0 3, these are multiples of each other. We can just multiply this by 19 over 3. Okay, if we multiply fourth row by 19 over 3, then we can produce 19 there, or we can multiply this by 3 over 19, then 19 cancel, then we get 0 0 3. In any case, we can get rid of one of the columns, one of the rows. Okay, so, or we can divide by 19, we can divide by 1, so we don't need this. That means, look, for these 3 columns we got pivot in each column. We were looking at 3 vectors and we got 3 pivots. Okay, that means these are linearly independent. So these are linearly independent. That means, what is the basis? Basis for this subspace H. So basis for H is just collection of V1, V2 and V4. V1, V2 and V4, or we could have written V1, V3, V4. That would work as well. V1, V2, V4, which are these. Okay, so what is 1500 and negative 3010, and now V4 is 04 negative 13. Okay, and as you can see, these vectors are coming from R4, so H is subspace of R4. You don't need that, but this H is subspace of R4. And here we got 3 elements for basis, so dimension of this subspace is 3, because there are 3 basis vectors. What we essentially showed here, instead of working with these 4 vectors to generate this H, instead of 4 vectors, we did not need all of them. We could have done the same thing using these 3 vectors. Final.